To find a reasonably priced 3-phase 7-terminal kilowatt meter, consider several avenues. Firstly, online retailers like Amazon, where you can search for 3-phase 7-terminal kilowatt meter or specific models like Siemens 7KTXX. Secondly, DigiKey, that offers various options from brands such as Eaton and Schneider Electric. And thirdly, Mouser Electronics, that stocks a wide selection of kilowatt meters, including 3-phase models with 7 terminals. Also check with electrical distributors, such as Gringo, which carries a range of kilowatt meters from reputable manufacturers, Wesco Distribution, that provides an extensive inventory of electrical equipment including kilowatt meters, and Rexel Electrical, which offers a variety of 3-phase kilowatt meters with 7 terminals. You can also go directly to manufacturers like Siemens, which produces a series of 7 kT kilowatt meters designed for 3-phase applications, Eaton, that manufactures a line of Power Expert kilowatt meters with 3-phase capabilities and 7 terminals, and Schneider Electric, which offers the ION line of kilowatt meters including models suitable for 3-phase systems with 7 terminals. When selecting a kilowatt meter, consider several important factors. Firstly, accuracy. Look for meters with a high accuracy rating, such as greater than 1%, to ensure precise readings. Secondly, current rating. Determine the maximum current load you need the meter to measure. Thirdly, voltage rating. Ensure the meter can handle the voltage range of your electrical system. Fourthly, display. Choose a meter with a clear and easy to read display. And fifthly, budget. Kilowatt meters can vary in price, so set a budget and compare options within your range. It is recommended to contact several suppliers for quotes to secure the best deal, as prices may vary depending on the specific model, features, and availability. When selecting a kilowatt meter for a 3-phase system with 7 terminals, it's crucial to understand the electrical system's requirements and the meter's specifications. A kilowatt meter, also known as a kilowatt-hour meter or energy meter, measures the amount of electrical energy consumed over a period of time. In a 3-phase system, which is common in commercial and industrial settings, the meter needs to be capable of accurately measuring the energy consumption across all 3 phases. The 7 terminals on the meter are typically used for connecting the voltage and current inputs for each phase, as well as providing power to the meter itself. Firstly, let's delve deeper into the technical aspects of selecting a suitable kilowatt meter. Accuracy is paramount to ensure precise energy monitoring and billing. The accuracy of a kilowatt meter is typically expressed as a percentage of the full-scale reading or as a class designation. For example, a meter with an accuracy of 1% means that the measured value will be within 1% of the actual value. In commercial applications, it's generally recommended to use meters with a high accuracy rating, such as 0.5% or better, to minimize errors and ensure fair billing. Secondly, the current rating of the kilowatt meter should be carefully matched to the expected current load of the electrical system. The current rating indicates the maximum current the meter can handle without being damaged or providing inaccurate readings. It's important to select a meter with a current rating that is higher than the maximum expected current load to provide a safety margin and prevent overloading the meter. For example, if the electrical system is expected to draw a maximum of 100 amps on each phase, the kilowatt meter should have a current rating of at least 125 amps or higher. Thirdly, the voltage rating of the kilowatt meter must be compatible with the voltage level of the electrical system. In the United States, common 3-phase voltage levels include 208 volts, 240 volts, 480 volts, and 600 volts. A kilowatt meter should be designed to operate within the voltage range of the electrical system to ensure accurate measurements and prevent damage. It's important to verify the voltage rating of the meter and ensure it matches the voltage level of the 3-phase system. Fourthly, the display of the kilowatt meter should be clear, easy to read, and provide the necessary information for monitoring energy consumption. Most kilowatt meters feature digital displays that show the current reading, cumulative energy consumption, and other relevant parameters. Some meters also have additional features such as backlighting, multiple display modes, and remote communication capabilities. When selecting a meter, consider the display size, readability, and the type of information it provides. Fifthly, the budget is always a consideration when purchasing a kilowatt meter. Prices can vary widely depending on the meter's features, accuracy, and brand. It's important to set a budget and compare options within that range. While it may be tempting to choose the cheapest meter available, it's important to consider the long-term cost of ownership, including accuracy, reliability, and maintenance. It may be more cost-effective to invest in a higher quality meter that provides more accurate readings and lasts longer. Besides these key factors, there are several other technical considerations to keep in mind when selecting a kilowatt meter for a three-phase system. Firstly, the type of meter is important. There are two main types of kilowatt meters: electromechanical and electronic. Electromechanical meters use rotating discs and gears to measure energy consumption, while electronic meters use solid-state components and digital displays. Electronic meters are generally more accurate, reliable, and offer more features than electromechanical meters. Secondly, the communication capabilities of the meter should be considered. Some kilowatt meters have built-in communication interfaces such as Modbus, Ethernet, or wireless, which allow them to be connected to a remote monitoring system. This enables remote reading, data logging, and analysis of energy consumption. Thirdly, the installation requirements of the meter should be taken into account. Kilowatt meters are typically installed in electrical panels or switchboards and require proper wiring and connections. It's important to follow the manufacturer's instructions and local electrical codes when installing a kilowatt meter. Fourthly, the environmental conditions in which the meter will be operating should be considered. Kilowatt meters are typically designed to operate within a specific temperature range and humidity level. If the meter will be exposed to extreme temperatures or high humidity, it's important to select a meter that is designed for those conditions. Fifthly, the certifications and approvals of the meter should be verified. Kilowatt meters are typically required to meet certain standards and regulations, such as ANSI 12.20 in the United States and IEC 62053 in Europe. These standards specify the accuracy, performance, and safety requirements for kilowatt meters. It's important to choose a meter that has been certified by a reputable testing laboratory to ensure it meets the applicable standards. Considering the installation of the kilowatt meter, there are crucial aspects to consider. Proper installation is vital for accurate readings and safe operation. The meter should be installed by a qualified electrician who is familiar with three-phase systems and electrical codes. Firstly, before installing the meter, ensure the power is turned off to the circuit. This is a fundamental safety precaution to prevent electrical shock. Secondly, the meter should be installed in a location that is easily accessible for reading and maintenance. The location should also be protected from moisture, dust, and extreme temperatures. Thirdly, the meter should be securely mounted to a solid surface to prevent vibration and movement. This can affect the accuracy of the readings. Fourthly, the wiring connections should be made according to the manufacturer's instructions and local electrical codes. Use the correct wire size and type for the voltage and current requirements of the circuit. Fifthly, ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and inaccurate readings. Also, it's important to properly label the meter and the associated circuits. This will help with future maintenance and troubleshooting. The label should include the meter's serial number, the circuit it is measuring, and the date of installation. After the meter is installed, it should be tested to ensure it is functioning properly. This can be done by comparing the meter readings to a known load or by using a test meter. If the meter is not reading accurately, it should be checked for wiring errors or other problems. Now let's delve further into the specific considerations for a three-phase, 7-terminal kilowatt meter. The 7 terminals typically correspond to the following connections. Firstly, line 1 voltage input. Secondly, line 2 voltage input. Thirdly, line 3 voltage input. Fourthly, neutral connection for voltage reference. Fifthly, line 1 current input. Sixthly, line 2 current input. And seventhly, line 3 current input. These terminals allow the meter to accurately measure the voltage and current in each phase of the three-phase system. When connecting the meter, it's crucial to ensure that the voltage and current inputs are properly matched to the corresponding phases. Incorrect connections can lead to inaccurate readings or damage to the meter. It's also important to use the correct type of current transformers, or CTs, if required. CT are used to reduce the high current levels in the three-phase system to a low level that the meter can safely handle. The CT should be properly sized for the expected current load and should be connected in the correct polarity. In addition to the basic installation and wiring considerations, there are also some advanced features that may be available on some three-phase kilowatt meters. These features can provide valuable information for energy management and cost savings. Firstly, data logging is a common feature that allows the meter to store historical energy consumption data. This data can be used to track energy usage patterns, identify areas for improvement, and verify the effectiveness of energy-saving measures. Secondly, real-time monitoring allows you to view the current energy consumption and power demand of the three-phase system. This can help you identify peak demand periods and adjust operations to reduce energy costs. Thirdly, alarm functions can be set to alert you when energy consumption exceeds a certain threshold. This can help you identify potential problems and prevent energy waste. Fourthly, communication capabilities, as mentioned earlier, allow the meter to be connected to a remote monitoring system. This can provide centralized access to energy data and allow for remote control of energy-consuming devices. Fifthly, power quality monitoring can measure various power quality parameters such as voltage fluctuations, harmonic distortion, and power factor. This can help you identify power quality problems and take corrective action to improve system performance and efficiency. Furthermore, when comparing different kilowatt meter models, it's crucial to examine the specifications carefully. Key specifications include the voltage range, the current range, the accuracy class, the operating temperature, the communication protocols, and the certifications. The voltage and current ranges should be appropriate for the specific application. The accuracy class should meet the requirements for the intended use. The operating temperature should be suitable for the environment where the meter will be installed. The communication protocols should be compatible with the existing monitoring system. And the certification should ensure that the meter meets the applicable safety and performance standards. Before making a final purchase decision, it's also advisable to read reviews and compare prices from different suppliers. Reviews can provide valuable insights into the real-world performance and reliability of the meter. Comparing prices from different suppliers can help you find the best deal and ensure that you are getting a fair price. When contacting suppliers, be sure to ask about warranty options, technical support, and return policies. A good warranty can protect you from unexpected costs in case of a malfunction. Technical support can provide assistance with installation, configuration, and troubleshooting. And a flexible return policy can give you peace of mind in case the meter does not meet your needs. Remember to factor in the cost of installation when evaluating the total cost of ownership. If you are not comfortable installing the meter yourself, it's best to hire a qualified electrician. The cost of installation can vary depending on the complexity of the project and the electrician's rates. However, it's important to ensure that the meter is installed correctly to avoid problems and ensure accurate readings. After the kilowatt meter is installed and configured, it's important to regularly monitor its performance. Check the readings periodically to ensure that they are consistent with expected energy consumption. Look for any signs of problems, such as unusual readings, error messages, or physical damage. If you notice any problems, contact a qualified electrician for assistance. Regular maintenance can help extend the life of the kilowatt meter and ensure its continued accuracy. Maintenance tasks may include cleaning the meter, checking the wiring connections, and verifying the calibration. The frequency of maintenance will depend on the meter's environment and operating conditions. In conclusion, selecting and installing a three-phase, 7-terminal kilowatt meter requires careful consideration of various factors. By understanding the technical aspects of the meter, the electrical system, and the installation process, you can ensure accurate energy monitoring, reliable performance, and long-term cost savings. Always prioritize safety and consult with qualified professionals when necessary. Remember to choose a meter that meets your specific needs, budget, and performance requirements. Keep in mind that the information provided is for general guidance only and may not be applicable to all situations. Always consult with qualified professionals and follow local electrical codes and regulations.